In a survey about a change in public policy, 100 people were asked if they favor the change, oppose the change, or have no opinion about the change. The responses are indicated at the right. Find the probability that a randomly selected respondent to the survey opposes or has no opinion about the change in policy. So let's look at this table. A total of 100 people were surveyed. Out of the 100 people, 50 were men, 50 were women. Out of the men, 18 favor the policy, 12 oppose it, and 20 of them have no opinion. Out of the 50 women, 9 favor the policy, 25 oppose it, and 16 have no opinion. In total, men and women, there are 27 that favor it, 37 men and women that oppose it, and 36 men and women that have no opinion. Now, the probability that a randomly selected respondent to the survey opposes or has no opinion about the change in policy, we have to decide if these events are mutually exclusive or inclusive. Now, if someone opposes it or has no opinion on it, these are mutually exclusive events. I cannot pull out a person randomly from the group of 100 people and have that person voted for both. They can't vote for to favor it, to oppose it, or to have no opinion on it, right? They either favor the policy, oppose it, or have no opinion, but they cannot do two things or three things, right? They can't vote on all three, because then that doesn't make sense. You either favor it or oppose it or have no opinion. So these are mutually exclusive events. So to calculate the probability of A or B, that is the probability of A plus the probability of B. The probability of A, which is opposing it. How many people oppose it? 37 people oppose it out of the 100 people. So that's 37 out of 100. The probability of B is having no opinion on it. 36 people out of 100 have no opinion on it. So the probability of A or B is 37 over 100 plus 36 over 100, which is equal to 73 over 100, which is equal to 73, or 73%. Let's see another example. I have the same chart. Now I'm going to do this probability first. Find the probability that a randomly selected respondent to the survey is a man or opposes the change. Now, are these events mutually exclusive or inclusive? Let's look at the chart. I have men here. The first event is that the person that I choose randomly is a man. So that would be these men here, right? And that's a total of 50 men. So the probability that it's a man is, probability of event A is 50 out of 100 people. That's the probability of that happening, of me selecting a person and have it be a man. Okay? The probability of event B is that they oppose it. Look at all the people that oppose it. 37 people oppose it, right? Total. So the probability of having someone oppose it is 37 out of 100. Now, watch what happened here. Out of the people that are opposing the policy, there are 12 men included in that group, which I already counted in this first group of 50 men. So to calculate the probability of A or B, I have to add the probabilities, and then I have to subtract 12 out of 100, which are men. Okay, so that would be 50 and 37 is 87, minus 12 is 75 out of 100, which is 0.75 or 75%. For the second one here, find the probability that a randomly selected respondent to the survey is a woman or has no opinion. Again, let me change color so we're not confused with what we did with the men. The probability that it's a woman, the probability of event A is 50 over 100 because there are 50 women. The probability of B, that the person I select has no opinion, is this amount here. 36 total people have no opinion. So the probability of B is 36 out of 100 people have no opinion. Notice how the red groups intersect at 16 because 16 women that were counted in the first probability were also counted in the second probability because 16 of them have no opinion. So to calculate the probability of A or B, I need to add probability of A plus the probability of B and subtract 16 out of 100 from this group that I counted twice. Okay, so that would be 70 out of 100, which is 70%. And there you have it. On my next video, I will do, I think we'll do one more example, or we'll start on the complement. I'll see you in the next video.